Here we have a question that explain the input and output characteristics of the common base configuration of the BJT. So you know that you have three configuration: common base, common emitter, common collector. Anyone, always they are going to ask you. Okay, so common emitter is also very important characteristics. So they're having high values of gain in terms of current and voltage. Okay. So when particular configuration is given, then you have to decide what is the input terminal and what will be the output terminal. Now suppose here as given it is the common base configuration. So first we need to draw this circuit diagram. So the main part of this circuit is what? That is the BJT. So first of all we need to draw the symbol of the BJT. So BJT, here it is the common base. So common base means input terminal is what? Emitter. Output terminal will be collector. Okay, so the input terminal is emitter. So that's why we put the arrow mark here. So which branch having arrow mark, that represent the emitter, and this is the collector, and base is the common. Okay, so this is the B base, this is our emitter terminal, and this is going to be the collector terminal. So many students, what they're doing, they're not putting the arrow mark. Okay, without arrow mark, transistor symbol itself is the wrong. Now here we have taken NPN transistor. Why we are taking mostly NPN transistor means mobility of the electrons are higher in compared to holes. That's why we are taking the NPN transistor. After that, next what we have to do? We have to do the biasing. So for the biasing purpose here, we'll consider the simple circuit. So in that, we are going to give the DC supply here. Okay. So normally we are considering the forward active mode. So forward active mode means input junction should be forward bias. So what we have here? N. So emitter is where? That is the N. So this negative terminal of the supply will be connected to the emitter terminal. So that's why this connection is given like this: negative, positive. And this one we call as the BEE, since it is connected to emitter. Similarly, in the output side, again we are going to give the DC supply connection here. Okay, this is not our actual signal. Okay, these are the we are using only for the biasing. So again, what we have here? Collector terminal. Then what we have written? N. So this N should be connected with positive terminal. Then only it will be the reverse bias. So negative, positive. This is the BCC. So input junction we are keeping what? Forward bias. Okay. So for the understanding, forward bias, and output junction we are keeping as the reverse bias. Since in case of transistor, if you'll having already idea about this, so if you see that the structure of that, it's going to be like this. Okay, so emitter, base having less region, collector having more. So here we have taken NPN. So this is the base terminal, this is the emitter terminal, and this is the collector terminal, and this is the junction, emitter junction, and this is the collector junction. So now this for the input characteristics, that output parameters will be constant. So here output voltage will be constant. Okay. So that voltage what we have written BCC, and if you try to find the voltage between here base and emitters, that will write as the BCB. Common is what? Base is common. Similarly, here between emitter and base, what is the voltage? That is the BEB. Okay. So this is the common collector. So this is the this C is here. Okay. So sorry, here we have taken common base, right? So what will write here? BEB. Okay, we are talking only about the common collector configuration here. So here we'll have positive, negative, that all symbol we have to give how this current flow takes place. So that direction, if you see that base current direction will be here, this will be IB, and collector current will be IC. And if you see here, here also we have collector current only, so both are upwards, and emitter current will be downwards. And you know that emitter current is equal to magnitude is sum of the base current and collector current. In the vector form, this direction is like this, and base and collector current have same direction. Emitter current having opposite direction. So now we'll see the first input characteristics. Okay. So for the input characteristics, which parameter should be constant? Which parameter? So we are talking about the input characteristics, means output voltage should be here constant. Okay. BCB is going to be the constant here. So once we'll keep the constant value of BCB, corresponding emitter current and corresponding voltage between emitter and base will be measured here. So in that we have to plot the graph. So here we have input voltage, there we have EB, or you can write BBE, and current is what here? Emitter current. So emitter current is here in milliampere. It is the higher values, and here 0, and we'll have value 1, 2, like this you can take up to 7 and 8 milliamperes, and here these values are going to be 0.2, 0.4, like this you can take up to 1 volt. So for the particular value of BCB, okay, here this graph is going to be like this. Around 0.6 or 0.7, this knee voltage conduction will take place, since transistor is also combination of two diodes. So suppose here our BCB is 20 volt. Now we'll take another value of the BCB. For that again you will get the another waveforms. So suppose this is the BCB equal to 10 volt. Similarly, we'll get third one. We can have many variation like this. So we are taking at least one more. So here suppose BCB is equal to 1 volt. So what we are seeing here, when this reverse bias of the output circuit or between the collector and base is keep on increasing, then we are correct that current is also, you are going to see that how it is going to vary. Okay. So when biasing, even reverse biasing is mode, you are going to get conduction little early. Next, we have to see the output characteristics. So in case of output, what will be the constant here? So for the output characteristics, input current will be constant. So what is the input current here? Emitter current is the input current. So this one we are going to take as the constant. And the graph will be plotted between the output parameters. So in the output, what we have? Voltage between collector and base, and which current? Output current is the collector current. So this current is also in the milliampere. Now for the different values, so here you can write 0, and it will go again. The collector current we have 7 milliamperes, and this one we can take up to 20. So now for the initial, when emitter current is 0. So in that almost situation, we is going to touch this portion. Okay. So this will be IE equal to 0 milliamperes. So this region, what we call as here, cutoff region. So that is the discussion about cutoff, saturation, and all these things. Next, we are going to change the emitter current. So here you are seeing that from the backside itself, waveform is going to start. Okay, here we have, suppose emitter current is 2 milliamperes. Like this, we are going to increase the value of the emitter current. So this is the emitter current. Suppose we have 5 milliamperes. Again, we have emitter current. So here it is going to be. So this all saturation region. This is going to be the straight. So emitter current we have taken as the 7 milliamperes. So this region, okay. So we can show this part. So this is the call as the saturation region. Saturation region. Saturation region means both are in the forward bias. And the region between this is the active region. So we required always active region so that transistor will work properly. So this is the output characteristics of the common base configuration. So here again, you have current amplification. So current amplification factor. So what is the output current? So current amplification factor means it is a ratio between output current and the input current. So it is the common base. It is denoted by alpha. So this is represented by del IC. The output current is IC. Input current is what here? Emitter current del IE. Okay. So this is approximately equal to 1, since you know that base current is very less. So these are the discussion about common base configuration and their input output characteristics. So always any one configuration they are going to ask you for sure. So any configuration is given. So you have to decide what is the input, what is the output parameters, and you must have to mark the arrow mark at one branch of the transistor, which one you are going to mark as the emitter, whether it is your NPN or PNP, only direction of the arrow is going to change. Okay. Thank you. Thank you very much. Like, subscribe, and share.